This video is how to perform a Monte Carlo simulation in Quantum Excel without using a design sheet, sometimes called freeform mode. This video is part of a series of Monte Carlo simulation, and there's a link to that series page in the description below. For this example, we're going to use resistors in parallel, and you can see the schematic in the upper right-hand corner where there is R1 and R2 in parallel. The equation for impedance is R1 times R2 divided by R1 plus R2. To do this without the design sheet, what I need to do is create a column where this is the name of the particular variable, and then this is going to be the value. So for example, I will type in R1 as name, R2 the name of the other variable, and then the value for the first one will be 300, and the value for the second one will be 100. I also need to define the equation, so Z, the impedance, is equal to, and I just enter the equation for impedance, where instead of using R1, I use the cell of the value for R1, which is C3, and then I do the same thing for R2, which is C2. So that's R1 times R2 divided by, then R1 plus R2. Now that I've defined the variable names, values, and the equation, I am ready to make this a Monte Carlo simulation. To do this, I need to mark each one of these cells as an input. So I need to define C3 and C4 as inputs. I can do that in two ways. One is I can go up to Monte Carlo and click on the menu item Mark Input. The other is I can right-click on the cell, and then if Quantum Excel is running, there's a context-sensitive right-click menu Mark Input that performs the same function as using it from the QXM Monte Carlo tab. When I click on Mark Input, Quantum Excel will ask me the input name. I could either type in the input name as R1, or optionally, I could click on the box on the right, which allows me to set a cell reference for the name. If I click on the box and then click on the cell B3, now Quantum Excel defines the name as whatever's in cell B3. If I change the value in B3 later, it changes the name. I can choose the distribution. There's a long list of distributions that you can choose from. In this case, I will leave it as the normal distribution. And then the mean is now currently linked to cell C3, and you can see that it says that the current value is 300. If I wanted to change that value, I could now. You should also note that there's a little chain link icon to the left here, and that's your indication that you have linked it to a cell versus you've typed in a static value. And then I'm going to type in the standard deviation, which in this case is a given to be 2. At the top, you can see a picture of the normal distribution. Its mean is 300, and then the standard deviation is 2. When I click on OK, Quantum Excel will then add a text tip to the top that says that the distribution is normal, the mean is linked, and that the standard deviation is 2. I need to do the same thing for R2. So I will right-click on R2. I will come down to Mark Input. And then I can either type in the name or link it. I will link it as I link the first one. I might as well be consistent. It is again normally distributed, and we'll make the standard deviation be 2 as well. And then I click OK. For the output, impedance, it is an equation. And I can either, with impedance, I can come up to the Quantum Excel Monte Carlo ribbon and click on Mark Output, or I can right-click and choose Mark Output from the context-sensitive menu. When I click on Mark Output, Quantum Excel again wants the name. I will be consistent and link the name to cell B6. And then for the specification limits, they are given as the lower spec limit is 70 and the upper spec limit is 80. And then I click OK. When I do, Quantum Excel adds a text tip that says that that is a Quantum Excel output and the name is Z. I have now done all I need to do to set up the Monte Carlo simulation. I can click on Run and then choose the number of simulations. I will choose 1,000,000 simulations. And when I'm done, Quantum Excel gives me the expected value analysis output and the results of the simulations. I will explain the results in another video. And that is how you create a Monte Carlo model in Quantum Excel without using the design sheet, sometimes called freeform mode.